This video will review how to calculate a binomial distribution table. It comes from page 385, number 2 from the textbook. It says, prepare a table and graph for a binomial distribution, and the probability of success is 0.2, and the number of trials is 5. Well, the first thing we can do is say, if we know the probability of success, we know the probability of failure is 0.8. So let's go ahead and make our table now. If you remember, for binomial distribution tables, the little x just represents the number of successes. So in 5 trials, we could have 0, 1, 2, 3, 4, or 5 successes. Probably going to need a lot more room here. Make that longer. So what's the probability of 0 successes? Well, you'll need to look up the formula for binomial distributions, but to have 0 successes, you would have 5 choose 0, and then 0.2 to the power of 0, and then all of your trials had to be failures. That's 0.8 to the power of 5. I think that's a little small. I'll make these a bit bigger so you can see. So let's look at number 1. Number 1 corresponds to 1 success. Well, there's 5 choose 1 ways that can happen, and that success is represented by a 20% chance of success, so that'll have a probability of 1. This should look like a 0. This should look like a 1. And then how many ways can you fail? Well, you have 4 failures. Let's look at 2. 5 choose 2. Where am I getting these from? It's from the formula, but it's also nice to note is that your 2 successes are 5 choose 2, as in of the 5 trials, 2 of them are successful, which means this 20% happens twice, and this 80% failure rate happens 3 times. And then how about 3 successes? That means of your 5 trials, choose 3 of them to be successful, which means your 20% happens 3 times, and your 80% failure happens twice. How about your 4 successes? That's 5 choose 4 of them to be successful, 0.2 happens 4 times, 0.8 happens once, and finally 5 choose 5, and the 0.2 happens all the time. There's 0 failures. And now we just have to calculate all those probabilities using a calculator. What's 5 choose 0? I know what 5 choose 0 is. It's 1. I also know 0.2 to the power of 0 is 1. So really I'm just calculating 0.8 to the power of 5, which is, it's right over here, 0.32768. Okay. Next one. What's 5 choose 1? I know it's 5, but we'll type it in anyway. It's okay if you don't know it. Times 0.2 to the power of 1 times 0.8 to the power of 4. And we get 0.4096. Good so far. Next, what's 5 choose 2 times 0.2 squared times 0.8 to the power of 3? You get 0.0248. And remember, all these probabilities have to add up to 100, so the next one should be small. What's 5 choose 3 times 0.2 to the power of 3 times 0.8 squared? And we get a small number, not surprising, 0.0512. Next one, what's 5 choose 4? I know what 5 choose 4 is, because if it's just 1 less, there's just going to be a 5 as the answer of 5 choose 4, but I'll type it. Times 0.2 to the power of 4 times 0.8, and you get 0.064. Oh, I left out a 0 there. 0.064. And then the last one is 5 choose 5, which is just 1, and 0.8 to the power of 0 is just 1. So what's 0.2 to the power of 5? 0.00032. And so what we've done here is create a binomial distribution table, and you can check if it's right. I mean, you're not totally sure, but it helps to be confident in your answer. A binomial distribution table always adds up to 1, so we can add 0.32768 plus 0.4096 plus 0.2048 plus 0.0512 plus 0.0064. Let's just see where we're at. Equals plus 0.00032, and you get exactly 1, which gives me confidence that my answer is right. So this is how to set up a binomial distribution table.